Welcome back to Venture Recap, the podcast where we explore the frontier of innovation and the remarkable people shaping what comes next. I'm Matt, and today's episode is one I've been especially looking forward to. Our guest today is a pioneer in one of the most technically demanding and globally transformative areas of deep tech, autonomous systems. For decades, he's been at the forefront of developing machines that perceive, decide, and move independently through the world. He leads one of the most respected research groups in the field, the Oxford Mobile Robotics Group, and holds the title of BP Professor of Information Engineering at the University of Oxford. His work has shaped the way we think about robotics, machine intelligence, and the future of transportation. He's also the founder and CEO of a company that's translating cutting-edge research into real-world autonomy, bringing AI-powered mobility into places that matter most: cities, industrial sites, and logistic hubs. And on a personal note, he's someone I'm proud to call a dear friend, a brilliant thinker with a great sense of humor and a deep commitment to building technology that actually works in the real world. He's a commander of the Order of the British Empire, a trailblazer in robotics, and one of the most inspiring people I know. Please welcome to the show, Paul Newman.
Oh, Matt, I mean, where'd you go with that? Thank you so much. And for a British person, I just lied a little bit there, right? Because the best way to do it is like, hey, there's this guy I know called Paul, we should have a chat. And then the guy called Paul will go, hey, let's have a chat. So thank you so much for inviting to your show. And how cool, right? Because you've known each other for what, 3-4 years now, and that's been outstanding. Hey, so let's get into it and just speak of a transformed world, eh?
Yeah, for sure. So let's start at the beginning. You've spent your career straddling the worlds of research and real-world application. And what drew you to engineering and robotics in the first place? Was there a particular moment or influence early on that set you on this path?
Yeah, so look, I'm an addicted maker. I'm just, engineers are the synthesizers. Like everything around you, unless you're in a forest and how beautiful, has been engineered, has been synthesized, and we're constructors of the world. And I guess you can look back, some of my earliest memories were taking the toys that I was given to bits and figuring out how they worked. I mean, there was a horrific story. My mother was really shocked. I must have been like 4, and she bought me this sort of like, it was like a automated puppy. It was rubbish. This was like what, 1976 or something, and you pulled a string and this fluffy thing sort of walked, but I skinned it. Like, so I took all the fluff off it and I pulled it back to its motors, and there was stuff hanging out. I said, Mum, look at this, how this works. And so I can remember all the way back to always building stuff. And here's the thing about robotics. Oh my word. You get to write a text file, a program, although now you write programs that learn how to learn now, but we'll come to that in a moment. You get to write a text file that makes stuff in the world move in a way that's useful and valuable. And that has never got old. Every single robot system that I've built that's been autonomous, that thrill when it goes and does it by itself has never got old. I remember when I was at MIT working on subsea vehicles, the moment you press dive and it flips and it disappears and you're like, I got nothing to do but listen to Mozart for 2 hours now and hope it comes back. That is a thrill. When your software passes some space readiness stuff for the European space mission to Mars, that's pretty cool. When someone sends you an image and say, hey, look, this is a fish from the bottom of the Mariana Trench that I took using your software. Or you stick your daughter, and she's 4, in a self-driving vehicle that you made, and you punch the go with beans button and off she goes. What a rush. And do you know what's amazing about all of this? Is that it makes the world a better place. That's what engineers do. They're always fixing the world. And why I am so privileged to be living at this time is round about now, in this 20 years, we're starting to build the machines that liberate us from stupid ideas that haven't really evolved since horses start drawing carts, where you still have to have one human per vehicle in the vehicle. That's all about to change. And that's been my sort of life's work, is changing how machines move such that they always know where they are, they always know what they should do, they always know what they should share, and then we can get to the useful, safe workforce. And what a privilege. And then when you fold into that, the people you get to meet, the challenges you get, the brains you get to form and alter, and how they alter you, well, what a privilege. So like, I gave you a lot there to pick up on. I gave you like about 30 things that you might go, yeah, what, how did you get into it? And a bit of a soliloquy, but I hope you get some of my founder's fire and just joy for what I do.
Thank you so much. That's really very inspiring and a fantastic introduction to the world of autonomy, the world of robots. So what does the world look like when autonomy is widely deployed, not just in cars, but across logistics, industry, and infrastructure? And where do you think we're still underestimating its potential?
Right. Hey, have I ever talked to you about Walls of Yellowstone? Have I ever done that one? Okay, you're going to, right. So you're going to go, oh my God, what's this guy doing? Why is he now? I asked him a simple question and what's he doing? So just hold with me for a while. So a while back, humans reintroduced wolves into Yellowstone, apex predators, right? And they're glorious. I mean, who doesn't like a wolf, right? Okay. But well, one thing that doesn't like wolves are elk, right? Because, you know, their preference is to not be eaten. Okay. So the wolves would particularly eat the unhealthy elk. So perhaps the herds of the elk got a little bit healthier, but also generally they don't like being eaten. So they run, right? Which means they don't overgraze. So the herds are now moving through and they're not overgrazing, and the flowers come back, and then the bees come back, and the pollinators come back, and the pollinators come back, and things start to grow, and saplings aren't being overeaten. So trees start growing on the riverbanks, okay, which is great. Because when the heavy rains come, I can see your face going, where is he going? But keep with me. So the trees are on the riverbanks, and when the mud starts to, when the rains come, the mud doesn't go into the river. And so the rivers become cleaner. Excellent, which means the fish come back and the beavers come back. And then the beavers start to dam the rivers, and the rivers change their velocity, and the erosion changes, and the shape of mountains change. Wait, what? This is the same, that's called a trophic cascade, where you induce one change at the top of an ecosystem and the whole thing pivots, right? That for me is what self-driving vehicles will do and what autonomy will do, because you get to reinvent stuff that you weren't able to change because you had to have one Homo sapien in every vehicle, whatever it's doing. And when you can invert that, and you can have one human looking after 170, 1,700 vehicles remotely, you get to change the shape of the vehicle, you get to change the price point of the vehicle, you get to change the range of a vehicle, you get to change the price point, you change efficiencies of having lots of vehicles working collaboratively in a way that humans can't do because they can't communicate in the way that machines do. You get to change defense, you get to change exploration, you get to change logistics. Our airports are going to change. Look at, next time you're in an airport, look out the window and think, my word, there's a lot of different vehicles there. Right? And they're all doing something similar, something that can be autonomized. They're doing fetching work, they're doing transport work, and it could be carrying sewage or cucumbers or suitcases or security. They're all vehicles that are moving in industrial logistics. I see that as a place where we would see an enormous transformation of where we have machines. So I see it changing how the workforce works as well. One of the examples I love is return to work mums in Perth, because they have rough sleeping patterns, coming in and working for 4 hours, but running a mine 3,500 miles away because they're supervising a mine. I think it is going to be astounding. And, it's now called physical AI, sure, but it's actually called robotics, right? So, machines that can make local decisions, they can share data, they can act, they can change the world, they can dig, they can do construction, they can run security operations, they can move stuff, and they can do that better. It's going to upend the way people and goods move, just in the way that the wolves have upended what happens at Yellowstone. And a line that I like very much at the moment that I'm using is pretty much everything around you there, Matt, either flew or shipped. Just think on that. Very little of it grew local to where your home is, right? Most of the stuff probably went on a plane or was on a ship at some point. And that's where I'm thinking. that's what I'm thinking about upending, is all of that logistics, because at the moment it really hasn't been innovated. And for me, that goes right back to Sydney in what, 1995, 1996, when I started on this, and we automated down in the University of Sydney ports in Port Botany, and then up in Brisbane. So it's kind of full circle in mines. I really think that we've got fixated a bit on passenger cars for autonomy, and that's kind of like not first, and is everywhere else. Everything that moves, everything flew or shipped.
I'm very interested in sort of the way you see the world, first as an engineer, as an academic, and then from there into commerce as an entrepreneur building a company. How have you made that shift? What led you down that path? Because they're completely different. I know you're still very much involved in academia, but going from one world to another, maybe efforts like this and maybe companies like yours will bring the two worlds together. I'm a huge proponent of working very closely with universities at any size and scale, not just Oxford or, Stanford or Harvard. We'll talk a little bit more about Oxford in a little bit. Mm-hmm. But what are your thoughts about that? Should academia and business kind of come closer and closer together?
Yes, of course. Like you have brilliant minds in both. Yeah, and you have brilliant energy in both. And one of the things that drives me nuts is when someone sticks the word just and then they use a noun. Someone is just someone is, a business person. They're not really, academics. What does that mean? Like, what I'm interested in is individuals that invent. That I'm attracted to people that go, I see it's done like that, but I was having a think last night and I reckon we could do it like this. Right now, there is something special about universities that's the primary thing they're looking for is, well, I was having a think, so I thought I'd have a go. Right. But something's changing. I mean, perhaps it's a bit like, the move of silicon fabrication and doping technologies in universities in the 60s into industry. That was quite permeable. And I think now with AI, machine learning, robotics, that boundary is quite rare. There's a generation of academics, and my experience was leading a successful academic group is like being a CEO. So let's just pull that apart. You've got to get your funding, right? Because no one's going to pay you. You've got to get your funding, you've got to sell it. Yeah. You've got to recruit. So you've got to be like inspiring enough for brilliant people to come and say, yeah, I'll spend 3 years working with that guy because I reckon those ideas sound pretty interesting. You've got to be a publicist. You've got to get it out there. You've got to be a communicator. You've got to get out there. You've got to be a finance director. And so I think I cut my teeth in the uni, starting to run a group of 45 people. I was contracting. I was learning about IP management. I was contracting with big defense companies and small SMEs. You've got to manage your relationships. You've got to be able to produce, if you like, business plans and research plans, but handle the uncertainty, because the dullest thing in the world is a research plan that you know is going to work. Like, what's the risk in that? Yeah. You've got to be able to follow your gut and go, it's not working yet, but I bet it will. That feeling of like, oh, it hasn't worked. Has it not worked because you implemented it wrong, or was it just a stupid idea? How can you tell? Right? Those are instincts that you have to have when you cross into business as well, I think. And I sort of blended the two, the stuff I learned about, IP, leading teams. I love the idea of success is when someone takes an idea that you seeded and then feels it's theirs. That's a win. Yeah. That's about leading brilliant minds and enabling them because, hey, they're smarter than you. You should always be thinking that the human you're talking to now is way smarter than you, and you should be enabling them. And how, because that's the way to scale, right? You still do need to figure out how to provide a direction, because you could go at 90 degrees because brilliant minds can do that. And how do you nurture them? How do you build your unicorn farm? And haven't I just described a great business there? And so that segue wasn't particularly challenging. Now there is stuff that happens in business that doesn't happen in academia. and vice versa. So you just got to suck that up and become good at that as well. Hire people around you who'll complete you. Like, so a big mistake a founder can make, I think, is going, yeah, I got all of this.
Yeah, along the same lines of what you're saying, I personally refuse to work with anybody who is dumber than me.
I mean, and it's also just a lovely way to be humble, right? Just, there are enough prats in the world. Don't be one more, right? I remember my supervisor, my PhD supervisor, he said many wise things to me. One of them was, he said, Paul, there's any number of smart people, but the rare ones are smart people that you'll want to spend your time with. Anchor yourself to them, right? And I really, that's just one of the advices that I've really taken, because if you really can build a good team and you adore being with each other, then you are going to have an exponentiated outcome. Yeah.
I think on that front, AI today and the tools that we have today are able to automate so many things. All the mundane tasks we can just automate using AI.
Yep.
Every day there are new platforms, new tools that are coming out.
Yep.
But that the human mind and the human brain, and there's even, I think, recent research about this, is that the way the neurons are working in the human brain is quite different than the way silicon chips work. And because of the way our brain is, we're able to create and be creative and imagine things in certain different ways, just at the fundamental level. So inspiration and imagination and creativity, those are very, very important traits, and certainly things that I look for in founders and really in life in general. So on that front, I mean, I remember during my brief stint in Oxford,
Yep.
seeing engineering students shepherding little robots through the streets, sometimes Carfax dodging tourists. In the early 90s, people would stop and stare, half amused, half intrigued, and stumbled upon a sci-fi movie. And back then, no one really knew if those blinking machines were
and now it's in your phone.
Student pranks.
Yeah, I mean, your iPhone thing, it's got this thing called Measure in it, right? And you can point your phone around and it measures distances and stuff. Yeah, that was the stuff I was working on my PhD, and how extraordinary. I mean, I can't really think of another era where we went through. Well, I mean, I'm fortunate, aren't I? Because when I remember when I first met my wife, said, "What are you working on?" Robots. Is this guy permanently geeky? Do you know what I mean? And so I had to rely on my humor there. Now it's the coolest thing ever. I mean, how extraordinary. I mean, it's in every newspaper that I open or read, or article I read. Pretty much it's always like, AI, are the machines thinking? No, they're not. What's it going to change? There's something extraordinary happen. It's a real privilege. It's kind of like living through the era of calculus turning up again, only it's accessible to everyone. It's utterly extraordinary. I think we've got some problems with it, but it is useful. And I'm really super, super happy that people have finally woken up that the real glory is when it's not, I'm a text generator. It's when that's going to affect a change in the physical world where, the machines, the software, I'm going to put software and ML all together, a digital form affects a change in the physical universe where bits meet atoms. I have just, there must be some extra bit in my brain, because since I first made my first programmable Lego computer when I was like 8, there was just something about that. It's like Descartes, just something about how can the physical world be manipulated by something like software. That is interesting. And I look at brains, I look at hedgehogs and go, hedgehogs are just extraordinary. And there's a real fascination for me about that. How do they represent space? How do they form a plan? How do they manage with uncertainty? How are ants so damn good?
Well, let me add something in there for you then. I think if there's one place where the line between imagination and reality has always been blurry, it's Oxford. I mean, this is the place that gave us C.S. Lewis, J.R.R. Tolkien, and
Inklings. Yep.
Even Dr. Seuss, who studied there too, though I doubt he wrote Green Eggs and Ham and the Ratcliffe Camera. So with all that in mind, how has Oxford shaped the way you think and see the world, both as a scientist and as a founder?
Yeah, I mean, what a privilege. So I got admitted to Oxford as an 18-year-old to Balliol College, and I read engineering science. And look, I remember calling my mum from a phone box, like in fourth week, 'cause the terms are only 8 weeks long, and saying, okay, this is a life event, because I'd been used to being the best at physics at school, and then suddenly I was a bit rubbish compared to everybody else, right? So that's a moment that everyone should go through, right, where you actually find out how smart you are. And there was something glorious about the way that Oxford taught engineering, in that you don't become an electrical engineer or a mechanical engineer, you become an engineer. It says you should know about electrical engineering, you should know control theory, you should know advanced math, you should know some quantum physics, you should know some aerial mechanics, you should know fluid dynamics, you should do structural mechanics. And so that put everything together. And so I think what that forced me to do was sort of understand that there's a common way to, the best skill is to simplify something with modeling mathematics, to go, well, that's just wildly complex, but what's governing that, right? And so that was the sort of the deconstruction step that I think I learned. And then in my fourth year, I then said, look, I think this robotics thing, there's something in it. And I was just taken by, computing can change physics, can move things. What's that loop from perceiving something to doing something because of it? And then I remember this moment, and I remember going, wait, hang on. There's this thing called information engineering, right? And what information engineering does is it inverts a relationship. And a sensor tells you something about the world. So let's take a camera, right? So a camera is actually weirdly a bearing sensor. Not a lot of people think along of it like that. So a camera gives you degrees, weirdly, because when I get a pixel, that's basically telling me that somewhere along a ray, there is something blue, but I don't know how far away it is. It's an angle, right? And along another pixel, there's something red. Okay, so my camera is giving me an observation. What I'd like to know, is it a traffic cone or not? That's what I'd like to know. Is it a traffic cone? But I'm getting angles to orange pixels and blue pixels and gray pixels and green and God knows what. I want to invert that. So I might have, I want the probability of cone given the image, right? But actually what I get is an image given that it's a cone, but I don't know it's a cone. So you have to invert this. And I remember there being this moment and going, wait, that's the same as stock trading. Like, I want to know what the price is now. I can see that, but I want to infer what it's going to be in the future. That's the same as detecting cancer in mammograms, because what I get is an X-ray, but what I want to know is the state, is there a tumor or not? So I get to see laser returns, but I want to know if I should be turning left. And that for me was a sort of a unifying thing that I really sort of discovered. And I was about 21, and then I went to Sydney and did that. And then coming back to Oxford, it has been an astounding, I never thought I would come back. I came back from MIT in 2003, and Oxford has treated me extremely well, in that Oxford tends to say yes. It tends to say yes, have a go, right? What you shouldn't do is just try and change something that's 500 years old, because they've kind of nailed that, right? But if you want to try something new, it's pretty much yes, yeah, and and for me, like I decided that I wanted to do something substantive. I remember sitting in my room in New College and going, I don't want to have a career which is an archipelago of great papers, right? I didn't want that. I wanted to build a mainland, right? And so I remember thinking, well, what I'm going to do is I'm going to start then building some really big systems. And if I build a big system, I don't know, a self-driving vehicle that's actually on the road, it's going to tell me what I should work on next. Because the first thing that doesn't work is the next thing, right? And I've had this model, like, okay, try and build something really big, something that's outsized for wherever you are. And that's exactly what OXA is. It's outsized, right? It's very ambitious. And that tells you what the next challenge is. And the glorious thing about robotics is you launch a robot in the world, within about 30 seconds, it will tell you what a Muppet you are and the bit that you forgot. That's how I've always set my research agenda, is I will, I don't know. There's a paper I did way back, like 2006, of I will send a robot around the cloisters of New College, which, by the way, is Harry Potter's school. So that's where it's filmed.
Of course.
Schoolyard. In doing that, I found all kinds of obvious things that I needed to get into, and they were next. And I've always kept doing that. So Oxford's been fantastic. And of course, let's not forget what's extraordinary about it. It's just not me. It's the individuals that are here and they're attracted to a system that teaches in a different way. It has a very different way of teaching. It has, you as taught as an undergraduate, you sit in what are called tutorials with one professor and maybe two undergraduates, and that's it. So then when I was teaching, I would find myself teaching quantum physics, some civil engineering, thermofluids I'm a disaster at, I got left at that, math, electronics, and that's been attractive. And then the quality of the individuals and the students that you get to teach and then they teach you has been extraordinary. And OXA is, I think, sort of a success story of a career progression that then happens as people can come through the university and go, now I want to go take that. And in fact, I sort of founded the business with the engineers that I'd built my research group with in the university as a spin out. And so that's a lovely, glorious story as well. And it's beautiful, right? Or at least one day a year.
Yeah, or some really, really warm summers, which is rare. But when that happens, it's fantastic.
Yeah, I think I can remember one in the late 90s. Yeah.
And of course, the university goes back to 10th century. So it's been there long before any of us were, and it's going to be there for a very long time.
And it stands for something
like that.
It stands for something. It stands for thinking hard and scholarship, right? That stands for something. It does. And as a repository of knowledge as well, like looking forwards and backwards. We have the study of classical civilizations, we have history, we have English, and we all mix together. I think that's incredibly important, and it makes it an extraordinary situation. I think I learned, when my time as an undergraduate, I think I probably learned more from the not engineers than I did the engineers, right? Because I got to be educated next to lawyers and historians, and that was good. Yeah, and academe stands for something. It really does. What it really stands for is like, I get to think, of course, whatever I want to think about. Where else do you have that freedom? Like,
very few places. Very, very few places.
Yeah.
Yeah. So you started your company after you received your PhD, after you've done a lot of other work, whereas some other entrepreneurs start their companies much younger in life. Some of them leave universities, renowned universities. I mean, we all know examples and so forth. Mm-hmm. And so for entrepreneurs or aspiring entrepreneurs, or even, high school students, kids listening to this conversation between you and me, do you think there's a formula, or do you think what is the best time to start a company, in your opinion?
Oh gosh. I mean, I don't think it's measured in age, right? I think it's measured in the situation that you find yourself in. Yeah. So, I don't think there was anything particularly special about me starting the business when I was like 41 or something at that point, with a colleague in the university. I think we decided to start it then because it was the right time, given the things that we had developed with the university, and was ready to start building something bigger and building customers with that. I think there's probably a sort of a maturity thing, and that's difficult because you probably don't know if you're mature enough until you have a go, right? So you've got to dive in the pool. I mean, I often think about what advice would I give entrepreneurs, and it's I would say steer away from anyone that's telling you things are black and white, because that's obviously nuts from just an entropy perspective. That's clearly not going to be true. As you grow your business, be aware that you're becoming the SME for your business. You're becoming the subject matter expert for your business. You probably do know the most about it than anyone else. But be careful that doesn't turn you into something that therefore you know everything, because experts don't need to know the whole thing. Be careful around that. You will find an unending stream of people that will tell you why you can't do it. don't need to listen to them and follow them. You need to be aware of what they're saying and be ready to pivot if actually that fits with your own data. So don't be obdurate, but do be stubborn. There's a difference, right? Because you have to, I call it persistence of thought. If you have an idea, okay, and it's different, it's because you will find resistance to it. It's very unlikely that everyone's going to go, yeah, it's just a great idea. You should go do that. Because if you do, you probably haven't got a moat, right? Because everyone's just going to go, yeah, I'm just going to go do that. And so it's having enough introspection and surrounding yourself with people that you trust that are going to tell you when you're being blind, right? A few people, and tell you, so like, yeah, go on, stick with it. I know that's really painful. And there isn't a formula, because if there's a formula, loads of people would do it. I would say index very heavily on people with you, because you probably can't do it alone. Probably can't. Pick some people that are loyal to you and you're loyal with, and you can share how you're going, how you're feeling, what those challenges are. Pick your investors very carefully. Thank you, Matt. Pick people who are going to be energetic with you. Okay. Pick people who are going to like take your energy, because you will be energetic, and add to it, but not take from it. Yeah, there are any number of people who will be resistors and will take your energy, and you need to energize them. Try and surround yourself people that will like multiply you by a number greater than 1. Okay, you will find people will be attracted to who are not that, and you'll need to think what to do about that. There's a thing I really liked, founders mode. I don't know if you saw that going around. I quite like it. I think there comes a stage where some people will say, okay, yeah, well, they're a founder. Yeah, okay. So great, really energetic to start with. And now we need some grown-ups, right? You probably can't do it 100%, but you've probably got it 70, 80%, but you need help on the 20, 30%. You probably don't need 80% help, because you're the founder and you're the subject matter expert. So be careful when you do that. I've seen many businesses get that done too early. So watch out for that. And above all, do it for as long as you love it. You have to love it. And it has been the joy of my life building this thing with the people, with the technology, overcoming the business challenges, being honest with yourself. It's a real addiction with only the positive side to it, like, because it's a fabulous thing and it will energize you. And so love it.
And what's your personal approach to, we all face disappointments, setbacks, things that we thought were going to happen that did not happen, or do not happen, will not happen. What is your approach? There's a ton of that in the journey of an entrepreneur, or in any journey.
Look, I did an interesting thing a couple of years ago. So I used to struggle with this, right? I find it really hard, and would sort of like end up sort of bottling my founder's fire. I was like, oh, that is so frustrating. It shouldn't have been like that. Like, that was insane. Why on earth did that C-suite in that giant company just rotate? So all the knowledge just got lost, and I'd spent 2 years building that. I mean, countless times that happens. And so what I did, it was building. And then I thought, you know what, I'm going to find myself a coach who can help me with living with Paul. I just phrased it like that. Okay, I'm going to find someone who will give me just an extra, just a view of how to think about how I'm thinking. And it totally changed my approach to disappointment and how I would feel in frustration and all those things that founders came across. And it's quite similar to, like, you've got a couple of voices in your head, and one's your amygdala, which is a sort of emotional response to threat. And I just learned to say, which part of me speaking? Is that my cortex, or is that my emotional response to a thing? And just having that second, like, just ability to step back from and go, okay, that's how you respond, Paul, in those situations, right? When that happens, Paul gets frustrated in the following way. That's what he does. Don't fight that. Normal service will resume in about 6 hours, and it's helped so much. And I wish I had that. I wish I had that earlier. Your family, talk to your family. I've brought them on every step. And my spouse, Sarah, she's been utterly fantastic in it. I don't think she really elected to be on this journey the whole time. Like, when she met me, I was going to be a geeky professor and work on robots, and now I'm trying to build something absolutely enormous. And then just sometimes just stuff happens, and that's just bad luck. It just is. There wasn't any more weekends you could work around that. Sometimes just stuff happens. So like, we went out and did our first funding round and COVID happened. And then we went out and then did again and Putin invaded Ukraine. That's just bad timing. There's nothing you can do about that. And I think that just comes with going around the block a few times. And love it. I'm going to come back to that again. The best antidote is you go home and you go, look, that worked. And I did that with Ben or Alex or Colin or any of the people that you adore.
And of course, in your position, you get to lead your firm. You get to set the tone for other people, younger people, engineers coming in and so forth. And so being able to label these circumstances, being able to see the situation from sort of a third eye, looking at the situation from a third person's point of view is certainly very, very helpful.
Yeah. I think engineering culture, I think it's really important. And I think, I haven't got it perfect, but it's a thing I strive for and think a lot about with the team as we leave it. Like, stuff just sometimes just doesn't work. That's okay, but you learn something. It's like the negative result of something that didn't work is really important. There's all these adages of sort of fail fast and, all that sort of stuff. Sure. But I think I like the idea of, I'm a huge fan of get things done in terms like you have a huge problem, make self-driving vehicle. Okay, so what's next? How do you do? You sort of get a foreshortening, a Lorentz contraction, and just work with the engineering teams and go, look, your instinct's probably good. Let's try that. Let's evaluate. Let's be honest with ourselves about why it worked, why it didn't work. Good engineering culture is thankful for ideas that were great for 4 years, but no longer any good. Thank you. I give thanks to that code. We're going to move on. I often say, build it such that when we meet our smarter selves in 6 months, we're thankful. I love that idea in an engineering culture, that your best self is probably 6 months hence of you. So are you making decisions now that's going to really annoy that guy in 6 months' time because you're being stupid now? How are you being open to what's coming? So don't choose a particular method and wedge yourself to that. Expect that the thing you're doing now is going to look a bit daft in 6 months' time. And my God, you better do that in an AI world. Yeah. Can you imagine making a bet on a particular algorithm or an approach and then saying, I have to stick with that? Yeah, it is expensive to swapping it out. Keep yourself open. The stuff that was a great idea in the 70s, because that still might be a great idea now. That's a huge thing, I think, in modern engineering companies is it's not always the thing that came out in the last year. Sometimes the stuff in textbooks from the 70s that are the right solution. Don't be afraid to use that. Talk about that. And how do you get that knowledge into an engineering company? Wow. That's non-trivial, right? Because you're probably not going to find that on YouTube.
And I know you like to share your knowledge with even sometimes perhaps competitors. I mean, I remember when our offices used to be in San Francisco. Of course, now we're in Sausalito. I'm not going to name the name of the company, but there was another autonomy company who was driving cars around the block, on and on and on. And I remember you and I talking about it, and you said, well, I think doing this via simulation is probably a better idea. And I know that you shared it with people because when I later on came across somebody who worked in that company, and I said, you guys considered doing the simulation instead of driving around the whole time. And they said, oh yeah, we started doing that. And I'm like, I wonder who told them to do that.
Yeah. I mean, so it was 2016 and 2017. And there was all this zeitgeist of look how many bajillions of miles we're driving. And I was here going, that's a terrible idea. Why are you not boasting about how few miles you need to drive? Like, what? That's mad, right? You should be saying, I need to be able to synthesize, is how we're talking next. I'm going to talk about Gen AI in a moment. I want to be able to synthesize the nightmares without having to wait for them just to turn up. And I was like, how dumb to go do the everyday thing, driving lots, hoping that the weird shit happens. Why don't you synthesize with Gen AI the weird things, right? So, and that's like what a dream is. Like you want to rehearse the awkward situations and find them. So yeah, I remember that, and I remember giving a talk at NVIDIA GTC around that, about using Gen AIs with autonomy systems in the loop, and I sort of talk about this very much. In fact, I use academia as the example here. Shall I do this one? I think you're going to love this one. So you can think about the student as the vehicle, right? And the student has to learn a set of skills that's to be great at driving around a port or an airport or a city, okay? And then how does the student learn? Well, the student learns by having a teacher, right? And the teacher can set some homework for the student, and based on the outcome of the student's homework, a good professor would go, okay, question 5 and 6, bit sketchy. Well, I'm going to generate some more homework about question 5 and 6. So what's happening here is the professor's generating a syllabus for the student that's customized to the student, right? And so my view of autonomy is that you would generate a syllabus for Heathrow, right? So the student's somewhat competent, goes into Heathrow, but there is some weirdness. And so using a Gen AI, it says, okay, I see around this part where you go underground, your perception wasn't so great. Let me generate you rehearsals for doing that. But that's a Gen AI problem. That is generating synthetic data that's conditioned on that part of Heathrow, because that's a syllabus about general driving specific both to the student and to the place. Excellent. Now, what else do professors do? They call their friend and say, look, I've got a student here called Bob. They're going to need to qualify Bob. Bob needs to have an exam set, not by me, right? But I've been teaching them, I've given them quizzes. Another professor needs to set that exam, because otherwise I could cheat. And I could go, look, all my students are great because I'm setting the exam myself. So you have to have an independent professor set the exam. That's assurance. That's the qualification. That's the certification of that vehicle. And then, of course, all of this can then be in a big loop because someone's got to teach the teachers. And so what Oguz's built is, yes, the student and then the professor, but then also the teaching system that equips the professor to be able to generate a syllabus that's really efficient for the student. And I love using this example because it's what I did in my, in my teaching career. That's exactly what I would do. When I have an intimate tutorial teaching session with a student, one-on-one, one-on-two, figuring out where they're weakest, generating teaching material to make them strong in that, and doing that loop. And then they go and pass their exams. And then because of the exams, they're qualified. And I like that analogy a lot.
I like it a lot too. I wonder if you give this talk over at Heathrow, half the employees are going, what syllabus are we going back to school?
It can happen. And then I show them, actually, here's a syllabus, and it's actually a movie of Heathrow in the snow, in the rain, with, different crowds of people, and go, that's what I mean by syllabus. And they mean, oh, you mean like what this place could look like under all these wild conditions? Yeah, because I'm teaching the machine about what could happen. Imagine how dumb it would be just to have to wait for all of that to show up. And here's the really interesting thing. I can then say, hang on, well, that syllabus then, that's actually the qualification. So if at runtime, this vehicle ever sees something that doesn't look like any of its rehearsals, you could have the machine go, wait, am I okay? Am I okay? Have I actually passed it? Am I qualified still? That's a really big idea. Probably shouldn't have given that away. But
well, I know you like to have an impact and tell people. I know you can't wait to tell more of what you're working on, and will come out in due time. But I know it's at the end of the day over there in Oxford. We're mid-morning here in the San Francisco Bay Area. But Paul, that was such a treat. Thank you so much.
Oh, thank you. Such a good interview as well.
Sharing your time and insights today, but for the way you continue to push the boundaries of what's possible while keeping it all grounded in curiosity and clarity.
It's a pleasure.
From Oxford's cobbled streets to the global stage of autonomy, your journey reminds us of the great engineering that's more about the technology. It's about vision, imagination, the courage to build things. And thank you so much. And to our listeners, if you enjoyed this episode, tell your friends about it, subscribe, leave a review, and share it. Thank you, Paul. Hope to see you soon in person. Try to make it out to Oxford maybe sometime this.
And I'll be out to the Bay Area again very soon.
Okay, of course, of course. Have a good weekend.
You're a legend. Take care, Matt.
Thank you. So are you. Take care.
Bye. Bye.
Bye-bye.